The simple O-ring, it may be an example of the most basic yet most elegant form of engineering. This O-ring can seal a housing, an underwater housing, and therefore make the difference between the success and the failure of your mission with 100% confidence if the housing is designed right, it is manufactured right, and you're using the O-ring in the correct way, installing it in the correct way. So it is simplicity translating to reliability. Let's start out by understanding how an O-ring really works. And that should help you understand why it works, why you can expect it to be so reliable, and under what conditions it can fail. We're going to talk about the type of O-ring that you see on many of the Desert Star products, including the SonarPoint underwater acoustic recorder or the ARC1 acoustic release. That is a side seal, also called a piston seal. And it's a very, very simple design. You have an O-ring sitting in a groove on the end cap. You have an O-ring surface in a housing. And when I mate the two together, I achieve the initial compression of the O-ring, and it is a perfectly reliable seal. Let's take a look at the mechanics of it here. So here you see an O-ring sitting in the O-ring groove, just like I have here, and this here is now the wall, the ID of your cylinder housing. You can see no water can get past it. Let's say the water came in from this direction. Now let's see what happens as water pressure increases. The O-ring now moves to one side of this O-ring groove, and you can see all the sealing surfaces here and here and here. And the sealing now under higher pressure actually has become better. So the seal for a side seal or piston seal O-ring gets better and better the higher the pressure is. There is a limit to it. Eventually, if you increase the pressure more, it will fully conform to this O-ring groove shape here. No more gaps anywhere around here. But the O-ring will start extruding out the gap between the end cap and the housing, so this gap must be kept very small. And then failure would occur when this process goes too far and you literally get O-ring extrusion like going through a cheese grater, and that's a failure point. That failure point would happen for Desert Star type designs at several thousand meters of depth, and so we use the side seal or piston seal due to its good properties for equipment that's designed for a service pressure of up to 1,000 meters only. Okay, so how could such a simple design fail? We're going to talk about this now into a few failure modes, because having a reliable seal depends to a significant degree on how you are installing and handling the O-rings. If you do it right, you can sleep tight at night and you won't have to worry about it. Your mission will be okay. If you do it wrong, you may well get a leak. The first failure mode we're going to talk about is specific to side or piston seal O-rings, and it's called something like, it's called O-ring pinching. So let's say I have an end cap, maybe I found an O-ring that was contaminated, it's time to replace it. I put a new O-ring in, like this, and And I don't bother to use O-ring grease. I say, it'll be fine. So that was mistake number one. Mistake number two, I don't check if this surface here is greased, and it's not, it's dry. Now I set myself up for a high friction environment and I might get a fail. Next mistake I make is I put the end cap on like this. Notice how it's fully seated on one side but not the other. And then I just kind of go like this. And I think, okay, it's good, I can put my screws in now and it will be fine. But not so. Take a look at this. I'm going to pull this out now slightly. Alright, so here we have the fail scenario. You saw how I put it in, all the wrong way, dry O-ring, not doing it evenly, and it did seem to seat, but when I pull it out, you notice a little bit of black here. That's actually a bit of the O-ring that has come out of the O-ring groove, and it is now pinched between the end cap and here, and that is a fail right there. That will in all likelihood leak. Even though I can push it shut, and apparently it seems to be all good, the gap is closed. Not so. You see the black in here. Now if I pull it out, of course now it reseated itself, you know, and if I put it in correctly, and we'll go over that later once more. So evenly now, and inspecting everything, this looks like good seating. And gently, a lot of feel to it. Yeah, it kind of clicked in here, and now it's fine. When I pull it out now, yeah, there's no black. See that? All seated properly. So O-ring pinching can happen quite easily, and you really want to watch out for that. At the end of this video we will go once more over the proper installation technique. Another potential sealing fail relates to devices that have wire harnesses associated with them, such as this ARC1 acoustic release, and there the risk is that you might get a wire caught between the end cap and the housing, therefore compromising the O-ring seal. So what you don't want to do with a device like this is just sort of, you know, like put the battery in here like this and this. And yeah, I could close it up, I could stuff it in here, but you can see there's a lot of wires floating around, and so maybe, you know, I'll mess it up. So take some time to just dress up your wire harness properly. Take a battery. I'll take this one here. I'll do it so you can see it perhaps. Kind of run the wire along the side of it, like this. And I'll do a similar thing here. Let's see if I can do that a bit nicer even. Here. And now it's all clean here. And I can put, with some confidence, dress up the final wire here. Alright. I'm watching how the wire is running, making sure it doesn't get anywhere near the O-ring seating area. And close it up. Now I can be confident that there's no wire in the way of the O-ring, and I'll have a reliable seal. Alright, let's see what happens if you do get a wire caught. Let's say you have a little loop here like this and you don't notice it. And now I'm putting it together. Well, in this case actually I would have seen it because it's just sticking way too much in there, you know. If it was a bit less of a loop, hang on, not sure if I can do it right, like this, Yeah, it's not easy right now, but sometimes it does happen where it seats fully, and yet there was a wire caught, and you can see that in here. If you look at this wire, see how it's squashed here now, you know, and here. So that's a typical thing that we see if a ARC comes back flooded, and we inspect this, and we might see, oh, there's a couple of flat spots here. So that means that wire was caught in there, and that can explain the flooding. All right, the next failure mode is a scarred O-ring surface or a contaminated O-ring, and maybe we'll wrap up in that also a damaged, say, cut O-ring. Here you can see this is the surface that the O-ring rides against, and I run up against it with my finger to make sure it's really smooth. I can use my fingernail here, and if my fingernail catches on something, I can't use the tube anymore, I'd have to use a new tube. The same is the case here, and the O-ring surface in here, in the groove. How can I tell, and how could it be scarred? Maybe somebody took a little metal tool to remove an O-ring. Never ever do that. Use a plastic tool like the O-ring extraction tool that we provide you with. That's safe because it's soft enough. Or if you don't have that, you can use also the corner of a credit card. And again, make sure everything is smooth in here. The O-ring itself has to be all the way smooth. You put a little hair in there, it'll leak. Some sand. Maybe the O-ring is old, has a cut in it. Maybe you pinch the O-ring and cut off a bit of the O-ring. So look out for all these things about good, clean, unscarred surfaces and a good, clean O-ring. Using the wrong sized O-ring is another failure mode. Notice here, this is the O-ring that belongs in there. This is a smaller version. Now I can stretch the small one and it will go on fairly easily. Maybe not quite that easy, but I'll get it in here. It's in, looks about the same, but now my O-ring compression, which for this housing here, most of our housings that use this type of O-ring is about 28 thousandths of an inch, 0.028 inch. This will now be reduced because the material is stretched and therefore it has to get thinner. So using the wrong O-ring will also cause a leakage hazard. Forcing your housing out of round is another way that you might create a leakage hazard here. And what I'm doing here is something I shouldn't be doing. I'm taking a hose clamp and I'm putting it right near the end of the housing. Let's say I'm trying to mount the housing on here. And then I'm tightening this. And going really nice and tight to make sure this thing doesn't come loose. Now I almost hurt myself here. Alright, let's see what happens now. I'll take my caliper here. I'm going to predict that the housing is now somewhat flattened. So what I'm going to do is take the caliper and just put it in here. This should be the flattened or smaller axis. I'll tighten my caliper here so you can see this now. Alright, this has no slop here, but when I go 90 degrees off, see how much slop I have. Let me actually give you some numbers on this. This is 1.741 on the short axis. Now I'm at 1.805, so that's a difference of 64 thousandths of an inch. O-ring compression would have been reduced by 32 thousandths of an inch. Remember, we only had 28 thousandths to begin with, so we could potentially have a leakage condition right here. There are certain design features like a fairly tight fit between this end cap and this housing that will help prevent that, but you still have to be careful about it. How do you avoid it? Rather than having your hose clamp on the end, put it in the center of the housing, like so. That should be plenty enough. Tighten it again. And now it shouldn't be out of round anymore. I can do another measurement here. This is the squashed or flattened axis, 1.783, and here along the long axis, let's see what I get here. I actually get 1.769, almost like it's less, so it hasn't been squashed at all. There's only a slight difference of 14 thousandths, so 7 thousandths compression change, and much of that is probably due to somewhat inaccurate measurement. So when you use a hose clamp, don't apply it at the end of the housing, but rather go to the center. Now let's say you're concerned about that nonetheless. You say, well, I don't really have that much control about how people are going to use it. Use a thicker walled housing. For SonarPoint, we have the 300 meter rated housing tube here and the 1000 meter rated housing tube. But even though you may not take your recorder to 1000 meter depth, this wall is much heavier, and therefore it will not deform anywhere near as easily as the thinner walled housing will do. Alright, let's look at how to properly install an O-ring and close your housing. It's really quite a simple process. Start with by looking at your O-ring seating surfaces and make sure by running your finger across it that they are nice and clean, there's no scarring. Same thing here, can't really get my fingers in here, but if there's any sign of contamination, what I like to do is I just take some paper towel and run it across here, looking at it all the way, making sure that everything is done just right. Next thing, I have my O-ring, and I made sure it is the correct O-ring for sure. There cannot be any uncertainty. If you have an uncertainty, don't use it. I'm going to take some O-ring grease to reduce friction on insertion and therefore reduce the chances of pinching the O-ring and also provide a better seal. Now notice I didn't put any gobs of it in there. What I want is a shiny surface. If I put gobs on it, it will attract dirt and you again raise your chances of having a contaminated O-ring and therefore failure mode. Again, I'm going to look at my groove. Everything seems to be nice. So you always do this work with much care and attention. Don't let yourself be distracted by anything else while you're doing this. This is a critical part of your job. And now my O-ring is inserted, and again I look at it and everything looks fine. Next thing, I want to make sure that the O-ring surface on the housing has some grease applied as well, so that the O-ring will nicely slide in. Okay. And now I take my end cap and I put it on here, but I do it evenly. And I look all around. Is there anything wrong with this picture? No, there's not. And then I evenly press it in, and I use my feel for it to see if it kind of clicks in. I don't quite like it. I'll adjust it again. Yeah, that clicked in. Alright, so I'm good. If I'm really nervous, I'm going to pull it out slightly. Not so much that the O-ring starts coming out again, but I want to make sure that I just see white here, that I don't see any of the black O-ring, and I don't. So I can put it in. Now here's a common question. Will your housing seal if you don't have all the screws in? And the answer is, of course it will seal, because you have achieved initial compression here already. To put on my reading glasses here to see the hole. So even if I had, say, just one screw half in, and I will throw it in the water, will it seal? Yes, it will seal, because the water pressure will hold the housing together, you know, so it can't come apart. Now, of course, having only one screw in or no screw in at all is a bad idea, because once you come back to the surface, you might knock the end cap somewhat, it comes off, or it might be warmer than it was when you installed the end cap, therefore the air inside will have expanded and will push the end cap off. So really the function of the screws here is not at all to seal the housing, it is merely to prevent the end cap from popping off. Okay. Now let's take a look how to take a recorder or an instrument apart. So I already removed 3 of the 6 screws, but notice the remaining screws I didn't remove all the way, but rather there's now a gap of about 1/10 of an inch between the thread and the head of the screw. And the purpose is that I'm trying to prevent, I must prevent, intrusion of any water, any salt water drops into the housing. And remember, it could be that the internal pressure is lower, maybe I'm in a cold environment relative to where I was when I sealed it, than the external pressure. And so if I were to just take the end cap off, any water droplets along here would get sucked into the housing at a relative vacuum, and if they land in the wrong spot on a printed circuit board, they may create a short circuit and may create corrosion. So again, the screws are partially removed, about 1/10 of an inch removed now, and then I take the housing and the end cap, and I just slide it up against them. It can't go any further. It's held in place by the screws, and now I can see this gap here, and I'm going to take a piece of paper towel and run it all the way through it here, making sure that I suck up any water that might be in here. Here we go. Now I'm ready to remove the screws all the way. Okay, now the screws are removed all the way. Now I could just kind of grab it here and go like this, but I wouldn't have very much control of it, and I still don't want to take any chances. So rather I hold it like this, I put my fingers over it and push the end cap out slowly like this, inspecting everything, and now I can remove it. And this is a proper opening of the housing without a risk of water intrusion. Alright, I started out this segment talking about how an O-ring seal, not despite its simplicity, but because of its simplicity, is perfectly reliable if designed and used correctly. And so I want to end this segment, this tutorial, with a story where that apparently wasn't the case, only I then realized it really is the case. The O-ring seal is reliable. So what this involved was a shipment we recently received of 100 housing tubes for the ARC1 acoustic release, so designed similar to the SonarPoint recorder, but from a new vendor. And it being a new vendor, we did a thorough incoming inspection. Every housing we pressure tested before using it in the assembly process. We always do pressure test every instrument, but that would normally be after it's been assembled. So we took these 100 tubes, and out of the 100 tubes, there was, I believe, 5 of them that flooded. A little bit of water coming in as we pressurized it to its service pressure of 300 meters for this 10-minute duration. And we repeated the test. It happened again. And I checked the O-ring surfaces, and they were fine. And I checked the dimensions, the compression, everything was fine, and yet it still leaked. And that made me worry for a moment. And it says, like, is my understanding of O-rings wrong? But then I said, no, it just can't be. The leak has to be something else. And sure enough, I got an inspection light here, and I put it inside the tubes, and it became quickly apparent that there's this sort of brownish line here. I'm not sure if it's going to show up. I marked it around here with the black lines, but the brown line runs kind of like here. And this is actually a crack in the housing. I could feel it as well in some of them. Yeah, here I can feel it with my probing tool here on the inside. I'm not putting it up against the O-ring surface here. There's a catch. It's a cracked housing. So these housings failed not because there was anything wrong with the O-ring, and there shouldn't have been anything because they had the proper dimensions, clean O-ring surfaces, good O-ring. In fact, it was something else, in this case, a cracked housing supplied by the manufacturer of these housings. Again, going to show that as long as your O-ring is properly used, you have the proper dimensions, there's no contamination, there's no O-ring pinching, it will be a reliable seal for your instrument. That's it.